Okay, I'm back to where we were. All right, so we've got the views. We've got it all on where we've got the scroll bar to disappear. Now let's look at making this dual axis chart from the lesson. If you drag in, so we got number of records, year built, so we can see that there was a building boom in the mid 80s, and then it went up again, starting around 94. That's pretty interesting. Let's look at how the houses got bigger over time. So if we take the heated area, that's the size of the house, and we just drag that onto the row shelf. We can see what happens here is that this marked shelf, let me backtrack for a second. You see this marked shelf, there was just one of them. And then when we added it, there became three of them. You have all, you have one for each, and then you have one for each measure. So some number of records, some heated area. Now that heated area doesn't make any sense to sum it, so we want to average that. So I can go ahead and change that default value to an average, but it doesn't change it up here, so I also have to change it up here, or I can just add it back. But we don't really want it to be a bar here because it doesn't really make sense. What we want to do is change that to a line. So if you click on the drop down, you can just change it to a line, and then you can so now we're going to make it a dual axis chart. So right now they're on two different, you have two different axes. You have one here for some number of records, one for heated area. Let's combine them into the same. So to do that, you just right click the second measure in your view and hit dual axis. So that's pretty easy. Now it automatically changed our number of records to a dot. We want to change it back to a bar. And this looks pretty good. So you can see that there's some wild stuff going on up here. And that's probably because these houses that are still around from the late 1800s are, there's only a few of them, only a few of them left, 26 from 1850. So anyways, let's create this last filter to say, okay, I want to say 1950 or beyond. If you drag year built to the filter shelf, what's going to happen? Because it's a dimension, you're going to have to go and select all of these different years. You can't use it as a measure and say, give me only years greater than 1950. So the way around this is to create a calculated field. Now we could drag it back over to here and say all values. Now this is going to filter at the row level, so it's going to say, is that house greater than 1950? So we say at least 1950, and then it gets what we want. The other way is to leave it as a dimension and create a calculated field. So this is I wanted to go ahead and introduce calculated fields because we'll be using them a lot. If you click this down arrow up at the top on the dimensions, or so you can click there, say create calculated field, or you can click in the white space on the data shelf, say create calculated field. And then we're just going to say after 1950. Now it's set as a dimension here, but you can still use it in a calculated field as a measure. So you type in year, and you see year built, and hit tab, greater than 1950. So this is going to be a Boolean variable. You don't have to set any variable types. So it's after 1950, it's going to say true, false. So for this row, is the year built greater than 1950? If true, then we'll keep it in. If not, then we'll leave it out. So we drag that Boolean onto the filter shelf, and we say, just give me the true values. So then we have the same view. Okay, so we can see from 1950 on, there's solid trend on year built. There's actually a trend line feature. We'll be looking at this later, but if you right-click anywhere on the view and set trend lines, show trend lines, and then that is the average heated area. Trend line cannot be computed. Okay, obviously I didn't try that before, but I guess it's because of the dual axis. Let's see. I think that about covers it. I'll do one other thing, is that generated map. I kind of skipped over that one, but if you double click, you notice that physical zip code is set automatically as a geographical variable. So if you right click that and say geographic role, it already automatically sees that as a zip code. So it's categorized right. So if you just double click it, it's going to create a map by default. It's going to generate a latitude and longitude, which you see down here. And notice you have just the terrain of the Raleigh area, which doesn't really help. I mean, if you want to make it more like Google Maps, you go up to Map at the top and hit Map Layers, I believe, and then you can change it and add in like roads, streets, and highways, I think is what we're supposed to do, so that you can see it more like a Google map. So there's your physical zip codes, and we can do something like, drag average heated area to the color, I think is what the view has. So then it's just going to actually draw out the boundaries of each zip code. So these are pretty powerful features. It's hard to do this just, with any other software program, really. But Tableau already knows it already has all the geocoding of all these different geographical features. It's already built into it. And you can explore that by going up to Map Layers, and you can see that there's all these different layers you could add in, per capita income, and then so it'll automate. If we take off our average heated area, no, that didn't work too well. Oh, by state, there you go, by zip code. So there you go. So it's some pretty cool features for you to mess around with there. I think that's all I'll cover for this week. Hopefully this helped you guys with the lesson. Yeah, feel free to give me an email if there's anything I didn't cover, and I'll or to send make a post on the help forum. Anyways, have a good spring break, you guys, and we'll be seeing you in a couple weeks. All right.